Howdy, y'all. Mr. Causey coming to you from beautiful Atascocita, Texas, with another homework helper. And today we're going to talk about Lewis dot symbols. Get your periodic table, and let's start. Some assumptions I'm going to make. I'm going to assume that you know what valence electrons are. I'm going to assume that you know the octet rule, the periodic table, and electron configuration or orbital notation. If you don't know these, you know you can go to my YouTube channel and find videos on all of these topics. All right, let's get started. The problem. Draw the Lewis dot symbols for the following: lithium, nitrogen, aluminum, and chlorine. Now we want to remember, Lewis dot symbols are symbolic representations of the valence electrons in an element. And valence electrons are the electrons in the outer shell, usually the s and the p orbitals. The dot format goes like this, and this isn't a hard, fast rule. Later we're going to kind of bend the rules, but this is a good way if you're just starting to learn about Lewis dot symbols and how they help you understand valence electrons. Because once you understand valence electrons, you're going to be able to understand bonding, and a lot of other things are going to make a lot more sense. So this is an important task. 1, 2, that's the s orbital, because remember now it's the s and the p's in the highest energy level. 3, 4, and 5. And why did I do that? That's the Hund's rule. Each of those orbitals must have one electron before pairing. 6 and 7. There's our 8th. And that fits right into the octet rule. We have 8 valence electrons, or the possibility of 8 valence electrons. All right, let's look at lithium. Lithium, there's the symbol. Write down the symbol first. Then go to your periodic table, and you'll note there's lithium, and lithium has 1 valence electron. So there it is. We're done. Now, by looking at that, I also know that according to the octet rule, lithium was going to give up that 1 electron. And because it's willing to give up that 1 electron, lithium is going to end up with a +1 charge. It's positive, as most metals are. Let's look at nitrogen. Write down the symbol, N. Find it on the periodic table. There it is. Count over. 1, 1, 2, 3, 4, 5. All right, there's 5 valence electrons. So let's place them. 1, 2, 3, 4, 5. Now that helps me understand why nitrogen has a -3 charge. According to the octet rule, nitrogen is going to want 3 more electrons. And because it wants to gain 3 more electrons, it's going to have a -3 charge. It's also going to have a possibility of 3 bonds. I learned that all from the Lewis dot symbol. Let's look at another one. Aluminum. Write down the symbol. Go to the periodic table. Find aluminum. There it is. It's number 13. And look. 1, 2, 3. That means it has 3 valence electrons. So let's put them down. 1, 2, 3. And this helps me to understand that aluminum is more than likely going to give up those 3. It's easier to give up 3 than to gain 5. So it's going to tend to have a 3+ or a 3 positive charge. Also, aluminum tends to have 3 bonds. Makes a lot of sense when I look at the Lewis dot symbol. All right, let's look at chlorine. Here's writing the symbol down. Go into the periodic table, and let's find chlorine. There it is. 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons. So let's place them. 1, 2, 3, 4, 5. Hund's rule. 6, 7. And by looking at this, I can tell that chlorine is going to gain 1 electron, because it's easier to gain 1 than to lose 7. And by gaining 1, it's going to have a -1 charge. And that -1 charge tells me that it's more than likely going to make 1 bond. All right, let's recap. You write the element symbol. You determine the valence electrons. You then draw the dots around the symbol following the pattern that was described here in the video. All right, as you